Hello everyone, and today we're going to do part 2 of section 2.1, which is function notation and evaluating graphs and with regards to relations and functions. So here we go. Okay, I gotta shrink this down a smidge. Okay, so given a table. So over on the right side here, you're going to see a data table x and f of x. And remember, f of x really just means y. Okay, we're going to be told to find f of 6. Okay, so the first thing we have to remember is function notation is f of x, equals mx plus b typically in a linear function. Okay, so now the f, the letters of function notation, indicate which function to use. Okay, so the letter indicates which function to use, and the number inside of the parenthesis tells you what x is equal to. Okay, or in a sense, x equals and then whatever's in there. Okay. And then this stuff over here, the mx plus b, is your typical linear function. M is slope, x is the x value. These guys are one and the same. And then your b value is your y-intercept. Okay? So looking at my first question, find f of 6. So we're going to use the f function. They only gave us f function. And they want to say, all right, when x is 6, what is your y value? That's what this thing says. Okay, so we look over here. Let's go to the 6. Okay, so let's go to when x is 6. So when x is 6, it tells me my y value is 4. So f of 6 is equal to 4. All right, so that was pretty easy. You just find where f of x is. Okay, so all right, so now let's take a look at the next one. The function g is defined g of x equals f of 2x. What is the value of g of 4? Okay, so basically what we're understanding here is that g of x is equal to f of 2x. So we're doing g... Oh, hold on, let me take a step back here. We don't need that. Okay, so we're going to start. Let's do f of 2x. Okay, so they want to do find g of 4, which equals to, we know it's f of 2x. So again, remember that whatever I put in the parenthesis is whatever the x is going to be over here. So this really translates into f of 2 times 4, or really f of 8. So now that I know what f of 8, we're going to f of 8. So this says, when x is 8, find the value of y. So let's come up to our table here. When x is 8, my y value is going to be 6. Okay? So f of 8 is equal to 6. And again, that's what this whole thing was equal to. So we can say g of 4, which is really equal to f of 8, which is really just equal to 6. Okay? Kind of confusing a little bit with function notation, so you just got to be very careful and think about what's going on with the problem. Again, if you're a little confused, you might want to rewind this slide and play it again, and make so you can kind of follow along already knowing what's going to happen next. All right, so let's move on. Okay, this one, multi-step process. Okay, we're given the function. Okay.
Hi.
Hi, Gwen.
I'm sitting with you.
Yes, you are sitting with me. Let the function f be defined as f of x equals x minus 5. Then they say 2f of p is equal to 30. Find the value of f of 6p. Okay, so we have technically like a 2 or 3 step problem here.
I got some markers.
Oh, that's good.
Books.
Nice.
Coloring book.
Okay, so let's start. We're going to start with this one right here.
Book.
Okay, so we're going to state 2 times f of p is equal to 30. Okay. So now what we're going to do is we're going to divide by 2 because I want to get rid of that scalar multiplier here. So f of p is going to equal to 15. Okay. Now again, you're sitting there going, well, what does that have to do with anything?
Bless you.
Bless you, Gwen. That's where now we're going to tie this piece in. Because again, a lot of students will say, well, gee, this really is not related, but they actually are. Okay, let me show you. So, f of x, it makes it hard to write when you're hitting my arm, Gwen. F of x is equal to x minus 5. But again, we say, well, I don't know what f of x is, but I know what f of p is. It's going to be 15. So believe it or not, what we're going to do is we're going to change the x to a p. And that's what students say, well, gee, can we really do that? Yeah, you can, remember. Because x is a variable, we can make it anything we want it to be. So we changed this to p. And again, based on what we know, this is the x, so that x now changes to p as well. Okay. Now we know that f of p is equal to 15, so we're now going to substitute that in over here. So 15 is equal to p minus 5. Then solve the equation, add 5. So 20 is equal to p. Great. Now how does that help us overall? Well, now that we know what this is, here, let me change my color of my marker here. Okay, now we're going to go to this, 6f of 6p. Now, knowing that p is equal to 20 in this case, we're going to fill that in for p. So f of 6 times 20, or f of 120. And again, students are going, well, that's great. What does that actually mean? Well, that's when we go back to this. Okay, so now we know that this equals p minus 5. Okay, so what I'm going to do now is I'm going to substitute this in. So f of 120 is equal to 120 minus 5. So therefore f of 120 is equal to 115. Okay, that was a really tough one because again, you got a lot going on, going from one function to another to another to another. So like I said, if you're not really sure, now that you have the answer, rewind the slide and look at it again now that you can know what's going on. All right, let's look at the next one. Okay, well, this one won't be too bad. Find x and y given a graph of a function. Okay, so for this first one, okay, here's our graph over here. We're told that f of 0. So they want to know when x is 0, what's your y value? Thank you, Glenn. So again, we look at our graph. Okay, so when x is 0, finding the y coordinate that associates it. So right there. So it tells me that y is going to be 2. So f of 0 equals 2. Okay, so it's just looking at the graph. Okay, let's look at the next one. We want to know f of 5. So when x is equal to 5, what's y according to the graph? So here's x is 5, so we're going to follow that up. And stop. Okay, so it looks like we hit right here, looks to be at 5. So when x is 5, our y value looks to be about 5 as well. So f of 5 is equal to 5. Okay. Now for the third one. This one's a little different. F of a is equal to 5. So what this is saying is, remember, f of x or g of x or w of x really just means y. So this time it's saying, all right, when y is 5, what's the value of x? Okay, so let's go to the graph. So when y is 5, oops. What's the only value of x we have? It's right there. It's when x is 5. So our function would say f of 5 equals 5. Oh, Gwen.
I love you.
I love you too. All right, so let's move on.
Oh.
Okay, number 5, evaluating a list of functions. Okay, so notice up on the top here, they give us a list of functions. G of x is this, k of x is this, h of x is this, and f of x is this. Okay, so remember what I said at the beginning of the film. Okay, the letter indicates which function you're using. Okay, so for letter A, says we're going to use the h function. So according to h, it's negative 2x plus, or 2x squared plus 5x. Okay. Now the 1 says we're going to put 1s in for x's. So now the x's, we trade out with 1s. Okay. And we solve this out. So we do our PEMDAS stuff. I'm going to zoom in so it's not as tiny. Okay, so we're going to do 1 squared, so negative 2 times 1 plus 5 times 1. Multiply, negative 2 times 1 is negative 2. 5 times 1 is 5. So negative 2 plus 5 is 3. So there's that one.
I can't find my regular tablet.
I don't know where it is, Gwen. Okay, let's look at the next one. Looking at g of x. So here's the g. Catch you later. So the g function, negative x squared plus 2x plus 1. And what we're going to do is we're going to substitute negative 2 in for the x's. So negative 2 being squared plus 2 times 2 plus 1. Now remember, we don't distribute. We have to go to the exponent power first. Negative times, that's negative 2 squared is 4. That's 2 times 2 plus 1. Okay. Now, since we're dealing with multiplication, now we can do the distribution. So negative 4 times 1, or negative 1 times 4 is negative 4. Oops.
I got a guitar and
Times this is plus 4 plus 1. And now combine your like terms. So negative 4 plus 4 is 0. Plus 1 is just 1. So after all that, the answer was 1.
getting one.
Okay.
I'm a guitar.
Alright, let's look at the next one.
Hey.
So we're going to start. We're going to use the k function this time. So the k function, according to our list, is negative x cubed. Okay, so we're going to start. This says we're going to put 5 in for the x. So we're going to do negative parenthesis 5 cubed. Now, order of operations says we do the exponent first. So negative parenthesis 5 cubed is 125. And then distribute the negative in. So get negative 125. Alright, let's look at the next one. First thing we do, let's identify our function. This time we're using the f function down here. So the x function's x squared. I'm going to kind of do this. So that equals to x squared. Okay, so now we're going to put 0 in for the x. So we're going to have 0 being squared. And we all know 0 squared is just 0. So f of 0. Okay. Let's look at the next one. H of 7. So our h function, again, is given by negative 2x squared plus 5x. Okay, so we're going to put the 7 in for the x's. So negative 2 times 7 squared plus 5 times 7. Okay. Okay. Now at this point, we're going to square first. Order of operations says so. So negative 2 times, that's going to be 49 plus 5 times 7. Multiply 2 times 49, that's negative 98 plus 35. So negative 98 plus 35 is going to be negative 63. So 8, oops. So h of 7 is equal to negative 63. Okay. Alright, let's look at this last one over here. Alright, so we're going to use the k function because looking at our value here, we're using k. The k function is negative x cubed. Okay. So in this case, we're going to put negative 5 in for the x. So negative parenthesis, negative 5 being cubed.
I don't like guitar.
Okay, so now we go the exponent. Negative, now negative 5 cubed is negative 125. And then times this in after, so negative times negative is 125 is positive 125. So k of negative 5 is equal to that.
Now what's it out?
Oh my goodness. Do what? Alright, so here we go. Word problem, creating a graph and interpreting it. So at the beginning of your 8-hour shift, you had 50 units of furniture that needed to be assembled. The number of units n that still need to be assembled during your shift can be modeled by the function n of t equaling negative 2.5t plus 50, where t is the number of hours in your shift. So step 1, graph the function. Okay, so we're going to start at 50, because that's my y-intercept. Okay. Now, then we're going to be going down 2.5 into the right one. Remember, slope is rise over 1 to 1. Okay, so it's going to be kind of tricky here, so I'm going to kind of zoom in on this a little bit. Okay, so we're going to graph. Negative 2.5. What? Down 2.5. Which is about, but notice, thank you. But notice we're between, our y units are going up by 5s, right? So again, that means half of 5 is 2.5. So we're only going to be technically going down a half and write 1. So right here. 2, 3, 4, 5, 6, 7, 8. Now I'm going to stop there, and I'll explain why in a minute. So let's connect our dots here. Okay, not exactly a great line. You should be using a ruler. Okay. So now, there's the graph. Now, I asked you to identify a reasonable domain and range. So domain, remember, are our x values. So looking at what I'm seeing here, what's a reasonable domain? Well, it said we work an 8-hour shift. Okay? So our domain is going to be from 0 to 8 hours, right? Between 0 and 8. Right? Because we work an 8-hour shift. We start at time. Here's your whole work shift right there, 8 hours. And that's why I stopped here, is because I'm not working overtime. I am only working 8 hours. Now my range values. Okay, now notice. Okay, my y's. We're going from between 50 and 30. Okay, so 30 is going to be less than or equal to y, which is less than or equal to 50, because we're between 30 and 50 units. Okay, so there's question B, reasonable domain and range. Now, C, what does the slope mean and what does the y-intercept mean? Okay, so our slope, our equation they gave us, here, I'm going to kind of scooch this up a little bit here. Okay, they gave us the equation y is equal, or yeah, y, we'll use y or n of t. It's negative 2.5t. I'm going to put this over 1, I'll explain why in a minute, plus 50. Okay. Now, the y-intercept is going to be the easiest one to start with, because this, according to our word problem, was our units of furniture. When I started my shift. So 50 is the number of units we had when we started. Now the slope, again, realize what that means. Negative 2.5 to 1 says we complete 2.5 units of furniture.
Okay.
Nice. Every 1 hour. So this top number is our units of furniture. And again, this bottom number is our hour. Okay. So that's what the slope and the y-intercept mean. Okay, then the last part of the question, how many units still need to be assembled when your shift is done? Well, as we said right here, that's our intersection here. After the 8 hours, we had about 30 units left. Come on. Okay. All right, so there's that one. So let's move on. All right, this one, they give us a graph this time. We just have to answer the questions. So it says, the position versus time graph below shows the motion of a skateboarder rolling along a horizontal surface. Imagine the starting line being labeled 0, and the position is the measured of distance away from that starting point. Calculate the slope. Okay, so I'm going to kind of zoom in on that one first. Now again, remember to find slope, m is equal to y2 minus y1 all over x2 minus x1. Okay, so we need to look at our graph and go get 2 nice points. So let's scooch over and look at our graph. Okay, so we want nice intersections if we can, so we don't have to estimate what that is. Now I see a point. This looks like a nice intersection right here, so that's the coordinate 0, 15. And then this looks like a nice one. That looks like a nice one. So you get your pick. So we have 0, 15. We either have 4 by, looks like 17 and a half. And then it looks like we have 8. Come on. 8 by 20. So, looking at these points, I would do these two. These look to be the nicest. So x1, y1, x2, y2. So we're just going to fill into our formula over here. So y2, 20, minus y1 of 15, over x2, which is 8, minus x1 of 0. So 20 minus 15 is 5. 8 minus 0 is 8. So our slope is 5/8. Now what does that mean? I'll write it as a decimal. So 5 divided by 8, whoops. 5 divided by 8 is going to be 0.625. Okay, so right as a decimal, there it is. Typically we'd leave it as a fraction, but all right. What does the slope of the line tell you about the motion of the skateboarder? Okay, well again, realize this is going to be over 1. So this is your difference of y's. The top number here is the difference in y. Bottom number is your difference of x. So based on my graph, looking at what my graph is talking about, my y values are my position away from the starting, and the time is my x's for seconds. So what does this slope say? Is that we're moving 0.625 meters every second. So answering my question, what does the slope of the graph tell us in this case? We move 0.625 meters away from start every second. Every 1 second. All right, now it says, write the equation of the line in y-intercept or slope-intercept form using function notation. Okay, so with this, let's start with slope-intercept form. Remember, that's y equaling mx plus b, where m is your slope, b is your y-intercept. Okay, so let's start our filling what we know. We know the slope is this. Y equals 0.625x plus, now my y-intercept, where does my graph meet the y-axis? Is right here at 15, so plus 15. Now, to put this thing into function notation, all we would do is replace y with p of t. So p of t equals 0.625 t plus 15. Okay, and there's that graph. All right, let's go to the last question. How long will it take the boarder to travel 300 meters? So we're looking for time given distance. So we're going to use our formula. 300 equals 0.625 t plus 15. Okay, so I'm going to minus the 15. So we're going to get 285 is equal to 0.625 t. Okay, break out our calculators for this one. We're going to divide by 0.625. Hey, Glenn. Oh, that's so nice. Thank you. Okay.
I love you.
I love you too, Glenn. All right, so 285 divided by 0.625 equals, we're going to get t is equal to 456 seconds. Okay, so it's going to take 456 seconds to get 300 meters away from the starting point. Okay. All right, so that's the end of this video. Hopefully you learned a lot, and I will see you next time.